Everybody, this is Teacher Yong Lam, and today in this video, we're going to talk about some commonly mistaken questions, right, that could be more challenging in your HAL mock test too. Now, first of all, I would like to really praise everyone, right, for their improvement because the overall accuracy rate for most of the questions have increased, right? Nevertheless, I have picked 7 questions with accuracy rate below 60% this time, right, to go through an explanation. So without further ado, let's start with question 9 from mock test 2. Now, as usual, this is a forming numbers question, right? And it's asking how many 3-digit odd numbers can be formed with the digits 0, 4, 5, and 7. Take note, there are no repeating digits in each number. So things like 777 cannot exist. Okay, now this is a question about asking how many numbers can be formed. You can either use enumeration or addition and multiplication principle. Right, so let's go through both ways. First way is by listing. Right, so if we are doing listing, you will need to understand what are the conditions that the number must fulfill. First, it must be a 3-digit odd number, meaning the ones digit must be odd. So the ones digit could be either 5 or 7. All right. Next, the digit at the front cannot be 0, right? Remember, the moment you see 0, you need to be very alert. 0 cannot be at the highest place, right? So that means your digit at the front could either be 4 or 5 or 7. So let's consider cases, right? What if my hundredth digit is 4? Then the tenth digit, we start listing in order from small to big, right? It could be 4, 0. Then I have 405, 407. You see, I'm listing in order from small to big, smaller tens digit, and then we look at the ones digit. Right, I have considered 405 and 407. Next, let's consider 4, 5. Now take note, I cannot have 0 because it has to be an odd number. Right, so we can only take 457. Then moving on, we will have 4, 7. And this time, we already selected 7, an odd digit. The only remaining digit for the ones has to be 5. So 475. Okay, so these are your 400 and something. Now let's move on to 500 and something. Right, it is 500 and something. Then the ones digit must be 7, right? Because that's the only odd digit left. So you can either do 507 or 547. All right. Moving on, 700 and something. You can either do 705 or 745 because once you selected 7 as your hundredth digit, then your ones digit can only be 5. So you have fixed it as 7 something 5. Now, take note, we are always listing from small to big, right? Smaller hundreds, then the next hundreds, then the next hundreds. Within each hundreds category, I'm going from small to big for my tens. Then if possible, small to big for my ones. So in total, we have listed 8 numbers. My answer is D. That's the first way of doing it though, using listing. Now, what happens if I want to use addition and multiplication principle? Okay, so that means we need to see how many choices are there for each digit. Now look at each digit again, right? Each place value. Your hundreds cannot be 0, so it's either 4 or 5 or 7. Your ones is odd, so it has to be 5 or 7. There are no restrictions for the tens place, by the way. So when we choose which digit, or rather which place value to start selecting from, we always start from the digit, or rather start from the place value with the most restriction, right? From the pickiest place value that allows the least possible number of values. Clearly, in this case, it is your ones digit, right? Your ones digit is 2 choices available. Either you choose 5 or you choose 7. Okay, so there are 2 ways to select your ones digit. Now, take note, the moment you select one of the ones digit, let's say you select 5, then the same digit 5 cannot appear in your hundreds or tens place. That means you have fewer choices for each of the other place values. So let's say I selected 5 lah. Okay, so let's say I selected 5. That means 5 cannot appear at the hundreds or the tens. Then now, what is the next place value with the most restriction? It is the hundreds, because your hundreds cannot be zero, but your tens could be anything. We have already selected one out of these two as our ones place digit. So that means there are two remaining possibilities for the hundreds digit. So that means there are two ways to choose. Finally, how many ways are there to select the tens? Now you might think, hey teacher, I select one more digit already. There's only one way left. But don't forget, you can still select zero, right? So there are again two ways to select the tens place. So with that, 2 times 2 times 2, there should be 8 numbers. And that corresponds to the 8 over here, right? So my hint here is, if you see that the number of numbers given is small, the options given are small, listing might be a good idea, right? But if your number of numbers get bigger and bigger, try to use addition and multiplication principle. Okay, so that will be for question 9. Okay, so now let's take a look at the next question, which is question 29. Now, this is a fraction word problem. Let's read the question. There were 800 books in a bookshop. 1 over 10 of all books were sold on the first day. Then 1 over 2 of all the books were sold on the second day. So take note, your all the books, we are referring to the total 800 books, right? First day, I sell 1 over 10. Second day, I sell 1 over 2. Now, on a third day, the school bought the rest of the books. The school bought how many books? Meaning, after the first 2 days, how many books are remaining, right? How many books are remaining? So when we see a fraction word problem, we can always think of it using a bar model. But this time, I have two fractions, right? 1 over 10 and 1 over 2. So my question is, the moment you see two fractions, are they referring to the same total or not? Clearly it is, right? Because they said all books and then they said all books. So they are all coming from the same total, 800, which means I can represent these two fractions directly on the same bar model. The problem is the denominators are different, right? 10 and 2. So before I can use a bar model or represent both of them on the same bar model, I have to make sure the denominators are the same, but I have to change them to the same denominator so that I can express them in the same bar model with the same number of units. Like this. So now let me see. The first day, I sold 1 over 10. The second day, I sold 1 over 2. I need to select a common denominator. Now you look at 10 and 2. To see what common denominator we can use, we find the LCM, right? Least common multiple of 10 and 2. And you realize it is 10, right? I can split 1 over 2, right? Make the denominator bigger, make it equal to 10. Now, from 2 to 10, I'm multiplying the denominator by 5. That means the numerator should also be multiplied by 5. It becomes 5 over 10. Okay, so now I have expressed both fractions as something over 10. That means the total, I can use a bar model to express it and split it into 10 whole units. Right, let's split into half first. Then each half I will split into 5 equal parts. So in total, I will have 10 units. And you already know the total is 800. So let's label over here. The total is 800. Now follow the question's fractions again. 1 over 10 of all books was sold on the first day. So out of the 10 units, 1 unit was sold on the first day. Then 5 over 10 was sold on the second day. So out of the 10 units, 5 units were sold on the second day. And the remaining was bought by the school. And the remaining is 1, 2, 3, 4. 4 units. So as long as we can find what is 1 unit, we are done with the question, right? Then one extra step will do, right? So we know the total is split into 10 units. So 10 units is equal to 800. So with that, 1 unit is equal to divide 800 by 10, which will give 80 books. 1 unit is 80. The school bought 4 units. So the school bought 4 units equals to 4 times 80 equals to 320 books. And that's how you get the answer for question 29. Express everything in a bar model. right? So this is actually what I've gone through in week 4, right, of the weekly practice. If you need more practice, you can ask me. You can look at the HAL book, or you can just revisit the live stream practices. Okay. Now, the next question is question 38. Now, this is a slightly weirder question, right? You need to understand what's the nature of the numbers given to you first. The sum of three consecutive odd numbers is 75. Now, I am giving you three consecutive odd numbers, right? For example, 1, 3, and 5. They are consecutive odd numbers. They are odd and they come one after another, right? Another example would be 9, 11, 13. Now, I just need to choose three specific consecutive odd numbers so that they add up to 75. Now, of course, you can list, or if we observe the pattern later, you will realize there is another systematic way to do this. Right? Anyway, we are asking what is the value of the largest natural number. So how should I do this? Right? Of course, you can check one by one, right? List out all the possible triplets. But let's observe the pattern, right? If I give you three consecutive odd numbers, what do you notice about the pattern? You will realize that from one number to the next, you will need to plus 2, right? One number to the next, you will need to plus 2. That means the difference between two consecutive odd numbers is 2. So you have the difference, right? The difference is 2 and 2. You also have the sum, 75, right? In this case, you don't know which three numbers there are, but you know their difference must be 2 and 2. The sum is 75. Sum and difference, what does that remind you of? Yes, it reminds you of drawing a bar model, right? So we can use a bar model to express the relationship of the three odd numbers and try to find each of them, right? So let's start off perhaps by labeling the three numbers. We have the smallest number, we have the medium number, and we have the largest number. Then we draw a bar model, right? Let's draw a line so that they have the same start. Then the smallest number will have the shortest bar. Okay. The medium number, we have a slightly longer bar. And the largest number, of course, will have a longest bar. Like this. Okay. And you know their total is 75. Now let's label their differences clearly. From the smallest number to the middle number, the difference is 2. Then from the medium number to the largest number, again, I need to plus 2. So then this difference over here will be 2 as well. Right? And then what about this part? This part is also a 2. Right? You see? So from the smallest to the medium number, I plus 2. From the medium to the largest number, I plus 2 again. Right? And then once you handle the extra part, you will realize that these three parts are the same. It's your 1 unit, 1 unit, 1 unit. Now, all you need to do now is to find out 1 unit using the relationship in the model, right? So we have in total 1, 2, 3. 3 units plus 2, 2, 2, right? 3 extra copies of 2. So that's 3 times 2 equals 75. Now, 3 units plus 3 times 2 is 6, right? 3 units plus 6 equals to 75, which means 3 units is 75 minus 6 equals 69. That means 1 unit will be equal to 69 divided by 3 equals 23, right? So that means 1 unit is 23, your smallest number is 23. So the medium number will be 23 plus 2 equals 25. And your largest number will be 25 plus 2 equals 27. So then you will get it. The answer is 27. If you don't believe me, just add them up, right? 23 plus 25 plus 27. Some of you who have better number sense will notice that 75 just nice is 3 times 25. So I can actually have an alternative way, right? Which is a special way where you just start from 25, 25, 25. To turn it into 3 consecutive odd numbers, I just minus 2 here, I just plus 2 here. That will give me 23, 27. And there you have it. You still get the same answer, 27. Either way works. Okay? So as long as you get the correct answer, either way works. Right? So this question is pretty special. You have a lot of ways to do it, depending on, right, what your number sense is like. All right. Now let's take a look at the next question, right? This is a math in discount question. Let's check it out. Now, each teddy bear costs $7. For every four teddy bears bought, the fifth teddy bear costs $4. Right? So imagine the first teddy bear 7, second 7, third 7, fourth 7, fifth 4. Now, Sam has 110. How many teddy bears can he buy? Now, let's say you are a smart customer like Sam. Would you buy the teddy bears one by one? Of course you won't, right? Because you realize if you bulk buy them, you buy five of them, the fifth one, you don't need to pay the full price. So actually, the key point in math in discount questions is that there will be an individual price, or what we call a unit price for one teddy bear. There is also a promotional group, right? One group. So let's see. Obviously, the unit price, the price for each teddy bear is $7, right? $7 for one bear. Now, how many bears can you group together in order to buy them at a cheaper price? You realize that you need to buy four teddy bears and then it's at the original price, right? But then the fifth teddy bear, you can buy it at a cheaper price. So fourth, normal. The fifth, you buy it at a cheaper price. So these five bears, I can actually combine them into a group, buy them in a cheaper price. So one group actually has five teddy bears. And now we need to find out five teddy bears, what's the price? The first four, you bought it at the normal price, right? Four times $7. But the last one, you buy it at a cheaper $4. So that will total up to 4 times 7, 28. 28 plus 4, $32. So you know, one group, you need to buy $32. Okay, using $32. Now, Sam has $110, right? His total is 110. Of course, if he wants to save money, he will not just buy the bears one by one. He will buy them group by group because buying in groups will save money, right? That's a cheaper bet. So let's see how many groups can Sam buy. Sam could buy one group first, right? $32. Then obviously he still have a lot of money, right? Then maybe he can buy another group, $32. Then maybe he can buy another group, another $32. Right. At this point, you will realize that Sam has already spent 32 plus 32 plus 32 equals $96. Do you think he has enough to buy another group of $32? Probably not, right? Absolutely not, actually. Because if I want to buy four groups, the total money I need will be 32 times 4, $128, which is not enough. He only has $110 in total. So after buying three groups, unfortunately, he doesn't have enough for the fourth group. How much money does he have left? Right, so we have 110 minus, now just now we already said, right, 32 times 3 is $96, right? So if I subtract 96 from 110, you will get $14, right? You will get $14. So he has an extra $14. Should he just keep the $14 in his pocket? No, he could buy more teddy bears, right? Then let's just see how many teddy bears can he buy in each of the amounts below. Now, first he spent $32 to buy five teddy bears, right? Because one group has five teddy bears, $32. Second group, five teddy bears. Third group, five teddy bears. How about the fourth group? $14. How many teddy bears can he buy using $14? Well, if he can't buy group by group, he can still buy one by one. And you realize that 14 divided by 7, which is the price for one teddy bear, is 2. Right? $7 for one teddy bear. Then if he buys 2, it will just nice finish up the $14 he has. So there you have it, right? He would buy 5 plus 5 plus 5 plus 2 equals 17 teddy bears. So in total, he can buy 17 teddy bears at most. Okay, so this is a math in discount problem. Most importantly, identify the unit price, identify the price for one group of teddy bears, right? The promotion group. Okay, let's move on to the next question, right? This is question 42, a page problem, right? In a 200 page book, the digit 2 appears for how many times in all the page numbers? Now, admittedly, this is one of the more difficult type of page problems, right? We need to identify where and when would a certain digit appear in a range. Okay, so usually how do we do it? Right, so usually the tip here is to consider by groups of 100. Right. In other words, we consider different cases based on the hundreds digit of the number. Now, if I have a 210 page book, then basically we are looking at pages 1 to 210. Your page 1 to 210, depending on the hundreds digit, I can divide it into several cases. The first case being, if my hundreds digit is 0, not 1, 0, because I always start from the first page. Okay, so the first group would be page 1 to page 99, my hundredth digit being 0. Now, since this is hundredth digit being 0, 2 could possibly appear only in the ones place and the tens place. So let's consider each case. For the ones place, how many times did digit 2 appears? In the ones place, digit 2 could appear in the following numbers: 2, 12, 22, 32, 42, 52, 62, 72, 82, 92. All right. So you see, if I only consider the one place, 2 appears for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times. Note that I do not consider these two first because this is at the tens place. I will consider it in the next case. Okay. So the next case is 2 could also appear in the tens place. So how many times did the 2 appear in the tens place? So we have to think about 20 something, right? So the first one is 20, then 21, 22, 23, 24, 25, 26, 27, 28, 29. Okay, and this time, how many times did digit 2 appear at the tens place? That will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Another 10 times. So to sum up, digit 2 will appear 10 times at the ones, 10 times at the tens. All right? So this is the first case of 1 to 99. Let's move on to the next case, right? What if I have 100 to 199? This time my 100th digit is 1, right? My 100th digit is 1. So again, let's start by considering from the ones place. Now, when does 2 appear in the ones place? In this case, right, it will be 100 and something 2. So it will start from 102, 112, 122, 132, 142, 152, 162, 172, 182, 192. Right? Perhaps you might already see the pattern. And yes, 2 appears for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times in the ones place. How about the tens place? Right. The tens place, now this time, when will 2 appear? It will be at 120 something, which we will start from 1 to 0, 1 to 1, 1 to 2, 1 to 3, 1 to 4, 1 to 5, 1 to 6, 1 to 7, 1 to 8, 1 to 9. So again, 2 appears for how many times? As I underline, you might have already noticed, right? It is another 10 times. So in the second case, right, 100 to 199, your 2 also appears for 20 times. Now, the last group is where you need to pay more attention. Okay, it's 200 to 210. This time, we still consider cases based on the place value, right? When will 2 appear in the ones place? It will be 2, 0, 2. That's the only incidence, by the way, right? 212 is out of range, so I don't consider it. There's only one time that 2 appears in the ones place. Now remember, the next case to consider will be the tens place. However, that will be 220 something. But we only reach until 210. 2 will not appear in the tens digit. So bye-bye, we don't need to consider that. Okay, does that mean we're done? Does that mean we're done? No. This time we are looking at 200 and something. And would you look at that? The hundreds digit is 2. So you also need to look at the hundreds place. Now, in this range, every number from 200 to 210 will have 2 at the hundreds place, right? Because it's 200 and something. So we can list out 200, 201, 202, 203, 204, 205, okay, 206, 207, 208, 209, and don't forget 210, right? So then the digit 2 will appear in all the hundreds place of these numbers. How many numbers are there? Don't say it's 10, okay, 200 to 210. There are actually 11 numbers, so 11 times, right? You can count, or you can just use the formula 210 minus 200 plus 1. Okay, so now we listed all the occurrences and counted all the occurrences of 2 in this range. If you add them up, you will get 52 as your answer. All right. So there are actually some patterns over here, right? If you're interested, I would share more in a later video or a later live stream, right? But in the meantime, just consider by groups of 100 overall, right? And within each group, you consider 1's place, 10's place, 100's place, right? Will it appear in each of the place values? All right, so that is page problem, question 42. Let's move on to the next question, which is also a tricky one, right? This is a cyclic problem, but I believe I've never gone through this before, right? So let's look at this question. The pattern says banana, banana, apple, peach, orange, banana, peach, orange, banana, peach, orange, banana. Now, immediately when you read this pattern out, you will realize that the repeating group is peach, orange, banana. Yeah, peach, orange, banana. Let me draw a rectangle to show this. Right, this is a repeating group. All right. Now, the question says, in this pattern, I don't know when I stop. I just tell you that there are exactly 36 oranges. So how many bananas are there? At least. All right, so how do we do this? So first, you already know that there are 36 oranges in total. Right, that's the only information you know. You don't know how many fruits are there in total. It's okay. Your step 1 will be to locate the 36 orange. Okay, so in order to better locate it, let's draw out the pattern again, right? Or rather, list out the pattern again in more detail. So the pattern has banana, banana, apple, peach, orange, banana, peach, orange, banana, peach, orange, banana. Okay, so then peach, orange, banana, you can keep repeating, right? Now, you already know peach, orange, banana form a repeating group. Now, this is the first repeating group, and the first repeating group has 1 orange. The second repeating group has the second orange. The third repeating group has a third orange. The fourth repeating group has the fourth orange. Now, if I have 36 oranges, where would the 36 oranges be? Where will the 36th orange be? In which group will it be? You see, 1 group, 1 orange, 1 group, 1 orange, 1 group, 1 orange. 36 oranges in total. You will realize that the 36th orange must be at the 36th group. Your 36th orange must be in the 36th group. And there you located the 36th orange. Now, all I need to do is step 2. Once you found the number of oranges and where the orange is, where the last target orange is, you just need to count the bananas. Now, in this question, it is asking you at least how many bananas are there. Now, you already know there are 36 oranges, right? And the 36 oranges here. If you want as few bananas as possible, how should you stop your pattern, right? Should you continue putting in this banana? Actually, you don't need to, right? Why? Because I already say there are 36 oranges. Once we reach this point, there are already 36 oranges. I don't care whether I put anything behind. The group doesn't need to even be complete. As long as there is the 36 orange here, then I'm fine. Now, if I want to have at least how many, then I should stop exactly. Stop exactly. Oops, I agree words. Stop exactly on the 36 orange. I don't move further. Right? If I don't go further, then I can ensure that up till now, here is the minimum number of fruits I need to have the 36 orange. Then all I need to do is to count how many bananas are there up till here. Okay, so let's just count. Before this group, I actually have 35 full groups, right? And each full group has one banana, one banana, one banana, one banana. That means these 35 full groups will give me 35 bananas altogether. From these 35 groups, I will have 35 bananas. Then don't forget, I still have two bananas in front of my distractors, right? It's at my distractor. There are two extra bananas. So then all I need to do is to add these two. 35 plus 2, there will be 37 bananas in front of the 36th orange. Okay? Now, common question. Do I need to include this banana? Don't need. When I say at least, the moment I reach here, I should stop it to ensure that the number of fruits I use is the minimum. The moment I reach the exact 36 orange, I should stop here to ensure that everything in front is enough. I only use everything in front to ensure I have the minimum number of fruits. Of course, if the question asks at most, you should keep going until you reach the next orange, right? But if it's at least, stopping here is enough. Okay, so this is a tricky one, but no worries, we will have more practices related to this. Finally, let's move on to question 50, right, which is a weight problem. Let me zoom in. Okay, now this is a rate problem, and it's also one of the commonly mistaken topics in the previous paper. So seems like you guys need more practice on this. I'll prepare that. Okay, now let's read the question. Two identical ants can finish eating 4 grapes in 2 days. At the same rate, how many grapes can such ants finish eating in 5 days? So you see over here, the outcome is eating grapes. Right. And there are two things influencing the outcome. First, the ants, right, which are the workers, the people doing the work, or the characters doing the works. And also, there's the time, 2 days. So in order to better visualize the information, let me just write it down. Right, two ants is the worker, can finish eating 4 grapes in 2 days. So two ants, if you give them 2 days, they can finish eating 4 grapes. Now, our target is we want 5 ants, 5 days. How many grapes? Right. So it seems like I need to change both the worker and the time at the same time. Right. So before that, teacher Yong Lam would like to share with you a trick. The trick is whenever possible, you try to find 1 unit. Right. What does 1 unit mean? Here I have 2 workers and 2 units of time. Can we possibly find out what is the outcome if I have 1 unit of worker, that's 1 ant, and 1 unit of time, that's 1 day? What is the outcome in this case? Now, let's take a look, right? 2 ants to 1 ant. Okay, 2 ants to 1 ant. Now, 2 ants to 1 ant, that is half the amount of workforce, so I divide by 2. If I divide the workforce by 2, then the outcome I will also divide by 2, which will be 2 grapes, right? But this is without changing the time, by the way. If I divide the worker by 2, my outcome will also be divided by 2. Half the amount of worker in the same time must do half the amount of work, right? Now, ideally, I should stop here. But did I finish finding the entire 1 unit? Not yet. This would be true if my number of days did not change. However, if I want to find unit, I also need to make sure my unit of time is, or rather my number of time is 1 unit, right? 1 day. So that means not only is my worker cut into half, my time is also cut into half. I already cut half for my worker. Now, if I continue to cut half to my time, my outcome will also still be cut half. So then 4 divided by 2, that will be 1 grape. So you realize 1 ant in 1 day can only eat 1 grape, right? So you can try to understand it this way, or if you think this is a bit too tough, it's okay. We can do separately, right? If I cut the worker into half without changing the time, then my outcome will also be cut into half. So then it will become 1 ant, 2 days, 2 grapes. Right. In 2 days, 2 ants can eat 4 grapes. So in 2 days, every ant can eat 2 grapes. Okay. Then I continue to cut half to my time without changing the number of ants. Then the outcome will also be cut half. Right. 1 ant, if you give it 2 days, it will eat 2 grapes. If the same 1 ant, you only give it 1 day, then it will eat 1 grape only. Okay, so now we have successfully found our 1 unit, right? 1 ant in 1 day will eat 1 grape. The question is asking 5 ants in 5 days can eat how many grapes? So again, let's change one by one. This time, from 1 ant, I want to make it into 5 ants. So I'm multiplying by 5. Every day, 1 ant can eat 1 grape. So if I have 5 such ants in a single day, 1 ant, 1 grape, 1 ant, 1 grape, 5 ants altogether, my outcome will also be multiplied by 5. That will be 5 grapes. Okay, but that is just in 1 day, But this time I want 5 days. So when I have more time, right, I multiply by 5. The outcome, of course, will also be multiplied by 5. So 5 ants can eat 5 grapes in one single day. Every day, 5 grapes. Every day, 5 grapes. Every day, 5 grapes. So the same 5 ants, if you give them 5 days, they will eat 5 times 5, 25 grapes. And that is how you get your answer. My tip here is whenever possible, find out the 1 unit rate. Right, that means 1 worker unit, 1 time unit. How much outcome can be done? All right, and with that, that is the end of the explanation for common challenging questions in mock test 2. Right, mock test 3 is already out, so hopefully everyone can get it done. If there's any more questions, I'll be happy to address them in another video. All right, so I shall see you when I see you again. Bye bye.